This video is the first of a few videos where we will review the last reaction type for our class, and that's the Wittig reaction. And this was discovered by George Wittig in the 1950s, and in 1979 he and his co-worker were awarded the Nobel Prize for this reaction. So this reaction is also referred to as an olefination reaction, and that's because it forms an olefin, and we'll talk about what that is as we go through this reaction. So here's the general scheme. Start with an aldehyde or ketone. So aldehyde or ketone starting material, and then we add something that's called an ylide. And so this is a triphenyl, so pH for phenyl ring, phosphorus, double bonded to a carbon, and then that carbon has two R groups. We're going to call these R prime to distinguish them from the ketone or aldehyde starting material. So this is called an ylide. And we'll talk about properties of the ylide in a little bit. So these two starting materials react together and form an alkene. So we take the two R groups and the carbon from the aldehyde or ketone. That is now double bonded to the carbon and the two R groups from the ylide. So here we have our alkene. And another word for alkene, olefin. So that's why we call this olefination. So you'll notice here in this reaction, we form a new carbon-to-carbon double bond. And so this is our desired organic product of the Wittig reaction. This molecule with a new carbon-to-carbon double bond. And the byproduct of this reaction is triphenyl phosphine oxide. So pH3 triphenyl phosphine oxide. Triphenyl phosphine oxide. So this is a very stable and very soluble product. And so its formation is the driving force of this reaction. The two starting materials are forming this really stable triphenyl phosphine oxide. So formation of this is a driving force. So if a chemist were to carry out this reaction, the olefin is the desired product, but energetically, the formation of the triphenyl phosphine oxide is what drives the reaction forward. As I've mentioned in other videos, forming a molecule with a new carbon-to-carbon bond is favorable and often desired in synthesis, in industry, in medicine. So we're changing the carbon bone structure of a molecule. So carbon-to-carbon bonds are desirable. New carbon-to-carbon bonds are